Today I'm going to talk about testing and how basically what how do we do tests in Python. And the talk is, I guess it's a bit longer than a lightning talk, uh, but we have time, right? And it's kind of, I guess it's pretty basic, geared at beginners, but it's also two-pronged. There's like the first part is more like philosophy. So what's the problem? Why is testing hard? Recently, I've come across this tweet by a famous Agile coach. I believe he's one of the signers of Agile Manifesto about testing. And if you're interested, I recommend that you look it up and read it. I'll post the link to my slides into the chat and on the Facebook event, so you can do that later. So what does he say? Essentially, he says, in the 70s, there was this approach or method of testing called black box testing, which is elegant on the ideal level. You consider your system as a black box with some knobs on the front, and you basically click the knobs and see what comes out without considering what's going on inside. So you just provide inputs and check outputs. And in the 70s, it was probably pretty a sensible strategy. The computers were small, like several kilobytes, or I don't know, tens or hundreds kilobytes of memory. And it was possible to make tests that completely tests the systems of the day in the black box fashion. But combinatorics is in play here, and nowadays it's much harder. Consider this: if we have a function that has 5 arguments which are Booleans, there are 32 combinations of arguments, so you can just write 32 tests and completely cover what the function can do. But if you add another parameter, which is also a Boolean, your test suite grows by a factor of 2. But what we have to do, or what we can do, is look inside the function and see that actually A is an independent variable. It does not interplay. What it does not influence how other parameters are handled and what they do, and we can kind of separate it into a separate test. So we can have a test where A is true or false, and then have 16 combinations of the other arguments. And what we've come up with is a gray box test, which is sort of like a black box test. We're still twiddling knobs on the black box, but we have some insight into what's going on in the internal structure of the system we're testing. Modern systems, of course, with the web, with asynchronous kind of universe, and the code sizes of code bases, it's just impossible to do a full black box test of any reasonably complex application. For example, if you have a web page with 10 fields and you test 3 values for each of them, the full black box test is 60,000 test cases. So we have to be smart. We have to think about what's actually going on and do trade-offs. And our tests are always incomplete and fragile, but still we have to make do and try to optimize what we have. Now, the practical part of the talk. In Python, tests come in 3 flavors, or you could make more, but generally there are unit tests, which are small tests testing individual classes, objects, or functions on their own. There are integration tests that are testing a larger aggregation of modules, objects, maybe bringing up the framework with the configuration. And then there are end-to-end tests where the system is tested in this black box fashion through its inputs and outputs, like through driving a web browser and checking what's coming up on the screen. So let's look at the examples. Here's a simple unit test. So, well, here we're imagining we have some small web application which can be written in any framework. My examples, it's Pyramid, and here you can see it in the models. The user is an SQL Alchemy model. So we're creating a user and we're checking that the dunder JSON dunder method creates a JSON representation with object. Simple, self-contained, no external effects. This is kind of the sweet spot, and these tests are really fast. You could run, I don't know, hundreds of such tests in a second. If you have some external dependencies, some library, network communication, some other systems that need to be brought up, what you do in unit tests is you stop them or mock them out. And mock or unit test.mock now in the standard library is a library that helps you do that. For example, here we have some method that sends an email and does that by calling the smtplib.smtp to create an SMTP connection. So what we're doing is we're patching it with mock, and basically we're creating a mock object that has a sendMail, which is a mock that can be called and returns this value when called, and we're just calling it, and then we're testing that the smtplib.smtp was called with these arguments, and then that the smtp.sendMail was called with these arguments. So this is also a fast, self-contained, isolated test that tests one function. But the risk with these tests is that when something changes, for example, the API of a library changes or some other conditions outside of our control, then this test will still work, but the code will be broken. One particular example of this was when migrating code from Python 2 to Python 3. People who had really good coverage, but with these mocked out isolated tests, could not really depend on the test suite to tell them if their code still works on Python 3, because a lot of the standard library libraries and functions got just reshuffled and changed in some ways. You needed to have tests that actually exercise them, import them to check out whether your code still works or not. So this is what we have with the unit tests. We need to test in more integration. And here's an example. For integration tests, we need to assemble these systems, bring stuff up, and we need to do some setup. And with PyTests, what you can do is have fixtures for your tests. And here's an example how a fixture bringing up an SQL Alchemy session for Pyramid looks like. So we're creating an SQLite engine, we're configuring, binding to it, and then we're creating an admin user so that there's like a user in the database. And that's it. Then on this yield point, it's fed to the test, and then it's cleaned up. we need to bring up our framework pyramid as well, and you do it by using the testing setup uh, function call also in the PyTest fixture. And then in the test, you're just providing these, declaring these arguments that tells PyTest that you need the DB session and the config fixtures from your conf_test_py file. And you just get these configured objects. You have the database ready and working and pyramid configured, and you can create a view and call it and check that the response is what you expected, and that actually here we're kind of mocking the cookie setting method of the security policy. We're checking that the cookie was set, so the kind of the authentication went successfully. Now, with these integration tests, also there are some risks that our integrations are testing some modules also in an environment that is not that realistic. So if our routes are misconfigured, or if the front end and back end code does not agree on the format of these JSON messages being sent around, we need something more: integration tests, or I mean functional tests, or acceptance tests, or end-to-end tests. So these are different names for the same thing, essentially. End-to-end is like a technological kind of moniker, because we're using a web application from the browser, end-to-end. Functional tests because we're using the whole system functionally, and acceptance tests because in some agile processes these tests are provided by the user and are considered as acceptance criteria. Does the system do what the user wanted it to do? So how do we go about setting them up? Well, you just install the plugins for PyTest, that PyTest Pyramid Server and PyTest Splinter. Splinter is a wrapper for Selenium and other kind of browser testing things that provides a high-level API. And you're getting Chrome driver to be able to run your tests with a real Chrome engine, either a real Chrome browser where you see how things are happening, or with a headless version where it's just happening and all you're getting is just errors or screenshots. Now, for this PyTest Pyramid server, you need to provide a testing ini, which is like usually you have an ini file for your pyramid application. So you're providing a different config for your application, which is used for the testing environment. And you see database and so on. Then with these fixtures, basically having installed these packages, you have the browser, session browser, and pyramid server fixtures hooked up. And when you require them, you get a server started and the browser fired up, and then you can just visit the server's URI with the browser, and then you can just wait for texts, click on buttons, fill functions, fill form fields, click, and so on. Now, if you want to see what's actually happening, you have to do this in PyTest ini. You have to, or you can provide command line arguments to PyTest, or just add them to your config file that you want Splinter WebDriver to use Chrome. Then instead of headless Chrome, then the browser will pop up and you will see your your tests running. Now, these are the three kinds of tests, basically what I wanted to talk about. And all of them have pros and cons. Unit tests, you can really get into all of the branches and test all the cases in minute detail, have high code coverage, but you have to keep in mind that unit tests don't have these drawbacks. They can still pass when the assumptions your code is making are wrong. So you need to have integration tests and end-to-end functional tests as well. And as I said, unit tests are fast. They're like 10 tests in a second or so. Then integration tests with Pyramid, I think it's starting and bringing down the app for each test. So it's, I don't know, a second per test or so. And the browser tests, basically each of these lines is on a magnitude of a second. It can be like 3 lines per second or so, but you can see just things happening in the browser. These texts are entered by sending the browser key press events, so it just cannot be fast. So this test would take, I don't know, 30 seconds, maybe a minute. But you still need all these kinds of tests in order to be reasonably confident that everything's working. And that's it. Any questions?
Thank you, Albertas, for this presentation. Yes, and feel free to ask any questions.
I can start. I have a question, like what percentage of time you spend for writing your tests, and like you had a long career. Did it change? Maybe you started without writing tests or started like spending 50% of time writing tests and it changed over time. Like what was the progress of your time that you invest into writing tests?
I don't know. I don't think it changed much. Well, I got lucky that the first job where I was programming Python, our employer also pointed us to extreme programming, had all the books about extreme programming, which is one of the early agile methodologies. And basically he insisted that we do test-driven development all the time. That's how I started. Basically all my professional Python code is test-driven. And as you know, tests are a significant part. After you figure out how to solve your problems, basically tests take not that much, but still they are good. Tests are usually more verbose than the code they're testing by a factor of 2 or 3.
Okay, thanks.
We have a question from Sharunas. He's being super active today. Thanks, Sharunas. What modules is better for microservice testing, for example, between 2 systems and microservice in between?
Oof. I don't know. There is this Python library called VCR, which lets you record responses of an HTTP, basically a HTTP session, and to play them back to make sure that your single system or your single service that's using other services over HTTP APIs is working. But still, I don't know. It's how would you go about doing or rigging an end-to-end test for a system of 3 services? You tell me, how do you do it?
Could you, there's another question. Could you recommend some worth reading literature about test-driven development?
Sure. So there is a good book called Test-Driven Development by Example by Robert T. Martin. It's like 20 years old or so. And its preprint is available, oh, it's Pike and Beck. Its preprint is available on the web. You just Google Test-Driven Development by Example PDF and you find the preprint.
All right. Thanks for the question.
So I
and thank you for the answer.
definitely recommend that book.
Great. Any more questions? Oh, I see Albertas posted a link to the book.